All right, for this lesson, you are looking at identifying discrete and continuous functions. A discrete function, the easiest way to think of that is it can be broken up into pieces. No, that's not a good way to say that. It's specific points on a graph. That's a better way to say that. Or it can't have, I don't know how to say that the best way. Let's just look at the graph for now. So a discrete function has a graph that consists of isolated points. So you see the first graph here on the key concept. When you're graphing a discrete function, you'll have a series of points. A continuous function has a graph that's unbroken, or it has the line. So when you're trying to identify them real fast, if you graph them, you'll know. Discrete has specific points on the graph, and continuous is a line. Let's look at example 1. Okay, so they ask you to graph the function y equals 2x minus 1 with the given domain. In A, what is the domain?
0, 1, 2, 3.
0, 1, 2, 3. So they've given you the x coordinate for 4 different points, right? So if I plug that into where the x is, I would get 4 solutions, as you see here. So for the first point, I'd say y equals 2 times 0 minus 1. So then that equals negative 1, right? So for this point, I'd have 0 comma negative 1 as the point. And you can see they've graphed it right here. For the next point, you just plug in 1, which gives you 1, so the next point is 1 comma 1, which they've graphed. Does it make sense on how I'm getting these points to graph them? You're just taking the domain that they've given you and you're plugging that into the x value, solving to get the y value, and that gives you the point that you graph. And then what kind of function is A? Discrete or continuous?
Discrete.
Discrete, because it's broken up into points. Now for the second function, they want you to graph the domain where x is greater than or equal to 0. That means it can be anything that is the x can be anything that is greater than or equal to 0. So you notice all they did was graph the line you see at the top, starting at my y-intercept, which is negative 1. So I put a dot down here at negative 1. And then what is x? Everything greater than or equal to that, right? So then I just graph my line, which slope is 2 over 1. But you notice it doesn't go down and to the left. It stops at that y-intercept because it has to be greater than 0. So it can't go to the left of this y line because x has to be 0 or greater. Does that make sense? And what kind of function is B? Continuous. Very good. Another way to think about it, this is what I was trying to think how to say earlier. When you have a continuous function, it's any part on that line and it can even be a half a part. So if you can break something up into portions, like if you're measuring a gallon of water, well, that can be broken up into different parts of the gallon, right? Half a gallon, quarter of a gallon, and you're still not changing. But if you're talking about, say, tables, how many tables are in the room, can I have a half a table? You can't cut a table in half. So that's how you can remember discrete versus continuous. Continuous you can have a part of, whereas discrete has to pretty much stay in whole numbers. All right, so let's look at example 2 here. You're going to tell whether the function represented by the table is discrete or continuous, and then if it's continuous, you're going to graph the function and find the value of y when x equals 1.5. So they've given you a table. Let me go grab a picture of it. And they want you to look at this and tell them whether it's discrete or continuous. Well, with what I just told you about portions of a part of a whole, if you had to guess, what kind of graph do you think this is?
Continuous.
Continuous, because they have a half and 1.5 as part of their function. But let's graph it to be sure. So this is the amount of rain. There's another clue. Can you have half an inch of rain, quarter of an inch of rain? Yes, you can break it up into measurements. However, when you graph it, can you have negative rain? So I don't need anything but quadrant 1 when I graph this because it has to be positive numbers. And then they give you the 0.1 and 0.5. So I'm going to graph that on here. So 1 and 0.5 would be about there. My next point is 2 comma 1. So over 2 up 1. And then my last one is over 3 up 1.5. Now they did theirs slightly different as far as how they did the measurements, and then if I could put my points better, this would all be on the same line. And you've graphed that, and you can see that it is a continuous line because it's the amount of rain can be anywhere along that line as far as measurements go. Does that make sense? Am I confusing you? I see confused stares. When you're measuring rain in a cup, it's got like 4 inches, right?
Discrete can't be like half the.
It's just the way they made it. I don't know that I know why. Dots? Well, but you have to have the dots to graph it. But when you're thinking about rain filling up a cup, it can be anywhere along this line, can't it? Whereas a discrete, you can't break it you can't put it in between. It's going to be on the whole numbers. Okay? So the question they're asking is whether this is continuous or discrete. We know that it is continuous. And then it says find the value of y when x equals 1.5. So first of all, do we know my y-intercept? Where does it cross the y-line? 0, right? Right here, 0. And can we figure out the slope? Remember, slope is
Y equals
y2 minus 1 over 15.
right. So if I say 2 minus 1 over 1 minus a half, 2 minus 1 over 1 minus 0.5.
1 over 0.5.
1 over 0.5.
2.
So 0.5 goes into 1 2 times. So my slope is 2x. And they want you to find it when x equals 1.5. So I just plug it in. Y equals 2 times 1.5. Well, what's 2 times 1.5?
1 point something.
Wait, no, because it'd be. Wait, 10.
1.
So 3?
1 point something.
Isn't it 0.75?
Wait, what?
Well, 1.5 can go into 2 at least one time. Huh?
But like if you're
We're multiplying.
Yeah, so if you
Multiply?
did 2 times 5, that'd be 10. And then you put the 0, and then you carry the 1. And then 2 times 1 is 2, plus 1 is 3. With the decimal point, that'd be 3.
1.5
Yeah, it would be
times 2.
3.
Yeah.
Because 2 times 2 is 4. 2
And then
times
you
2
put the
is
decimal
2.
point.
It's 3. Oh, I should
Yep. X is 1.5. Yeah, but if you look at my graph, it doesn't. It's right here.
I think y is 0.5. I mean, it's 0.5x.
What was the question when you solved for?
You can't go up 2.
It wants the value of y.
So the value of y is 3.
But look, the value of y on my graph is
The
not
slope
3.
is 0.5x because you're not going up 2 over 1. You know what I mean? You're only going up 0.5 every time.
Oh, I put the x on top. It should have been 0.5 over 1.
Yeah.
That's right. My slope was wrong. Yay, we solved it. Good job, Ben. So the slope is 0.5x. So then when you did this math, this should have been 0.5. So then my y value is 0.75. My fault. Can you tell I'm tired? Okay, so what you're going to be doing for is just numbers 1 through 9. 1 through 6, you need to classify them as either continuous or discrete and graph them. Well, so if you graph them, it'll tell you real quick whether it's continuous or discrete. And then for 7, 8, and 9, you're telling me whether they're continuous or discrete, and then you're solving for the y value when they give you an x. So you need to find the slope like we did. Correctly, though, not incorrectly like I did. Life happens. Okay, any questions? 9 problems, you can knock that out and be done.